projects. In this video, we are going to explain about the project title Phishing or Not Phishing, a survey on the detection of phishing websites. Introduction. Phishing attacks leverage psychological and social engineering methods to manipulate individuals into divulging sensitive information or performing specific actions, such as clicking on malicious links. While not technologically complex, phishing attacks are successful due to their ability to mimic legitimate websites convincingly, making it challenging for individuals to discern their malicious nature. Phishing attacks pose significant threats, including direct compromise of identities and accounts, financial losses for individuals and organizations, erosion of trust in online services, brand abuse and reputational damage to organizations, potential data breaches, and other financial impacts. The project aims to conduct a thorough review of the current state of detecting phishing websites. This review encompasses detection approaches, datasets, and research gaps. Objective. The project aims to study evolving phishing tactics used by attackers and stress the critical role of robust phishing detection to combat these evolving threats effectively. The project classifies phishing detection into three main types: list-based, using predefined known phishing URLs, similarity-based, comparing with known phishing or legitimate sites, and machine learning-based, employing machine learning algorithms for pattern recognition. The project focuses on assessing the effectiveness of detection features by understanding the strengths and weaknesses in distinguishing phishing from legitimate sites, while considering strategies employed by attackers to evade detection. The project stresses the use of well-defined performance metrics, accuracy, precision, recall to accurately evaluate detection models, aiding in the selection and comparison of efficient phishing detection methods. Requirements. The requirements of the project are hardware requirements, in which we have operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements, in which we have Anaconda 3 and Visual Studio Community version. Flow of work. To implement this project, we have designed the following steps. The first step is importing the packages. Begin by importing the necessary libraries for data manipulation, feature extraction, model building, and evaluation. Libraries like NumPy, Pandas, sklearn, XGBoost, Keras, and others might be relevant. Importing datasets. Load the Fishtank and Curly datasets into your project. These datasets likely contain information about URLs, domains, and potentially other features related to phishing detection. Exploratory data analysis (EDA). Perform EDA to understand the structure and characteristics of your dataset. This might involve examining data distributions, checking for missing values, visualizing data, and gaining insights into the data. Feature selection. Address bar based feature selection. Extract and analyze features from the address bar, such as the length of the URL or the presence of certain keywords. Domain based feature selection. Extract domain-specific features like the age of the domain, the number of subdomains, etc. HTML and JavaScript-based feature selection. Analyze features from the HTML content in JavaScript code in the web page source. This could involve detecting certain patterns associated with phishing attacks. URL-based feature selection. Extract features directly from the URL, such as the use of special characters, shortening services, etc. Data processing. The initial step involves collecting, cleaning, and preparing the dataset. This process ensures that the data is in a suitable format and structure for analysis and modeling. For phishing detection, this data could consist of website features, URLs, or related attributes. Visualization using Seaborn and Matplotlib. Data visualization using Seaborn and Matplotlib helps in understanding the dataset's characteristics and patterns. This step involves creating visual representations like graphs, charts, and plots to provide insights into the data and aid in making informed decisions during the analysis. Splitting the data to train and test. The data set is divided into two sets: the training set used to train the machine learning models and the testing set used to evaluate the model's performance. This step ensures that the models are assessed on unseen data. Building the model. This step involves selecting and implementing various machine learning and deep learning models for phishing detection. Multiple algorithms are chosen to evaluate their effectiveness and compare the performance in identifying phishing websites. Support Vector Machine (SVM). SVM is a powerful supervised learning algorithm that is used for classification tasks. It finds an optimal hyperplane in a high-dimensional space to separate data into different classes. In phishing detection, SVM can effectively classify websites into phishing or legitimate based on feature extracted from the URLs of web page content. Random Forest. Random Forest is an ensemble learning algorithm that operates by constructing a multitude of decision trees during training and outputs the mode of the classes from individual trees. It's effective for phishing detection by aggregating predictions from multiple decision trees to determine if a website is phishing or not based on various features. Logistic regression. Despite its name, logistic regression is used for binary classification tasks. It predicts the probability that a given input point belongs to a certain class. In phishing detection, logistic regression models can be trained to determine the likelihood of a website being a phishing site based on specific features. K-nearest neighbor (KNN). KNN is a simple and intuitive algorithm used for classification. It classifies the data point based on the majority class of its k nearest neighbors in the feature space. In phishing detection, KNN can assess the similarity of a website to known phishing or legitimate websites based on extracted features. Decision tree. A decision tree is a flowchart-like structure where each internal node represents a feature. Each branch represents a decision based on that feature, and each leaf node represents a class label. Decision trees can be trained to classify websites into phishing or legitimate based on features such as URL structure or content. AdaBoost. Adaptive boosting is an ensemble learning method that constructs a strong classifier by combining multiple weak classifiers. It focuses more on the difficult to classify instances, making it suitable for phishing detection by enhancing the classification of suspicious websites. Navy Bayes. Navy Bayes is a probabilistic classification algorithm based on Bayes' theorem with the assumption of independence between features. It is efficient and commonly used in text classification tasks. In phishing detection, Navy Bayes can predict the likelihood of a website being phishing or not based on extracted features. Gradient boosting. Gradient boosting is an ensemble learning technique that builds a strong model by sequentially adding weak models. It aims to minimize the loss function. For phishing detection, gradient boosting can be employed to improve classification accuracy by combining weak learners. XGBoost. Extreme gradient boosting is an efficient and scalable implementation of gradient boosting. It's known for its speed and performance in machine learning competitions. XGBoost can enhance phishing detection accuracy by building an ensemble of weak models. Convolutional Neural Network (CNN). CNN is a deep learning model commonly used for image and pattern recognition. In phishing detection, CNN can analyze website content or visual elements to identify patterns associated with phishing. Long short-term memory (LSTM). LSTM is a type of recurrent neural network (RNN) well suited for sequential data analysis. In phishing detection, LSTM can be used to analyze the sequential nature of URL or web page content to make predictions. Deep Neural Network (DNN). DNN is a neural network with multiple layers between the input and output layers. It can capture complex patterns and features from the input data. In phishing detection, DNN can be used to process various features for effective classification. MLP, Multi-Layer Perceptron. MLP is a class of feed-forward artificial neural network. It consists of multiple layers of interconnected nodes, allowing for complex learning. In phishing detection, MLP can learn and classify based on extracted features. Perceptron. A perceptron is a simple type of artificial neural network and serves as the foundation for more complex models. It's a linear binary classification model that can be used for basic phishing detection tasks. Passive aggressive. The passive-aggressive algorithms are a family of online learning algorithms often used for classification tasks. They work well in scenarios where data streams in and models need to adapt to changing patterns, potentially useful in evolving phishing detection scenarios. Initially, machine learning and potentially deep learning models are trained using labeled data. These models learn to recognize patterns and features that distinguish between phishing and legitimate websites based on the provided features. We applied ensemble method that combines the predictions of multiple base estimators and predicts the class label by majority voting. It can help enhance the overall classification accuracy in phishing detection by leveraging diverse models. Training the model. Initially, machine learning and potentially deep learning models, example SVM support vector machine, random forest CNN, are trained using labeled data. These models learn to recognize patterns and features that distinguish between phishing and legitimate websites based on the provided features. Flash framework with SQLite for sign up and sign in. The Flash web framework along with SQLite has the database is used for creating a web application. It provides functionalities for user registration sign up and authentication sign in, allowing users to create accounts and securely log into the application. User gives input as URL. A user inputs a URL through the front end of the web application. This URL is then sent to the backend for further processing. The given input is pre-processed. The user provided URL undergoes pre-processing to extract relevant features. This pre-processing step ensures that the URL is in a suitable format and structure for analysis. Features such as URL structure, domain information, and other relevant attributes are extracted. Trained model is used for prediction. The pre-processed URL is fed into the trained machine learning or deep learning models which were previously trained to detect phishing websites. The models predict whether the given URL is likely to be phishing or not based on the extracted features. Final outcome is displayed through front end. The prediction outcome is obtained from the models and sent back to the front end of the web application. The application displays this prediction to the user, providing a clear indication of whether the given URL is considered safe or potentially a phishing attempt. This process allows users to input URLs, have them analyzed for phishing indicators using trained models, and receive instant feedback on the likelihood of the URL being associated with phishing, all facilitated through a user-friendly web application. Comparison graph. This is the comparison graph of all the models. On the x-axis, we have the algorithm name, and on the y-axis, we have the evaluation metrics count. Models are compared with the parameters accuracy, precision, recall, FN score, sensitivity, and specificity. And each matrix is represented with a different color. Accuracy with blue color, precision with orange color, FN with green color, recall with red color, sensitivity with purple color, and specificity with brown color. So here we can see the performance of each algorithm. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I am typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which is this, localhost, and port, which is this. Now copy this local link provided by the Flask framework. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome. And hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button. Here we need to enter all these details to register, but I have already registered, so click on sign in. So here we need to enter the username and the password which we have created, and then click on submit. We have logged in. We need to type a URL to predict whether it is phishing or not. So I'm entering the URL. Now click on predict. So here we can see you are safe. This means that the URL which we have typed is not phishing. Now I will enter some more URLs. So here I have typed this URL. Now click on predict. We can see phishing websites detected. This means the URL is phishing. In this way, by entering the URL, we can predict whether it is phishing or not. The conclusion of the project is, the project's primary objective is to conduct a thorough and up-to-date review of the current state of the art in detecting phishing websites. This involves a detailed analysis of existing methods, techniques, and technologies utilized for identifying and combating phishing attempts. The review encompasses an in-depth examination of advancements, challenges faced, and notable findings within this field. Within the comprehensive review, the project delves into various aspects of phishing detection. This includes a discussion of different detection approaches such as machine learning, heuristic-based, and list-based methods. Additionally, it covers the types of datasets commonly used for training and testing these detection approaches. Moreover, the project identifies gaps in current research, areas needing further exploration, and potential improvements to enhance phishing detection effectiveness. The project underscores the importance of thoughtful feature selection in phishing detection. It advocates for a meticulous consideration of feature strength, weaknesses, discriminating power, and the strategies employed by attackers to evade detection. The principle of parsimony is highlighted, urging a balanced approach in selecting features that are both effective and efficient in detecting phishing attempts. The project stresses the significance of using diverse and unbiased datasets in training and evaluating phishing detection models. It also emphasizes the importance of employing appropriate evaluation metrics such as accuracy, precision, recall, and F1 score to assess model performance accurately. Furthermore, the project advocates for feature engineering to improve the predictive power of the models, enabling a more robust and reliable detection of phishing websites.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.